Hey everyone, welcome back to the channel. In today's video, we are going to talk about an essential PySpark function, the length function. This function is incredibly useful when you need to measure the length of strings, whether it's for validation, data transformation, or even cleaning up your datasets. By the end of this tutorial, you'll be able to confidently use the length function to simplify your string operations in PySpark. Let's dive right in. Introduction to the length function. The length function in PySpark is a handy tool that allows you to calculate the number of characters in a given string. It operates similarly to the len function in SQL and the length function in Python, providing a way to determine how long a particular string is. This can be especially useful when you need to work with text data such as product codes, names, or descriptions. By measuring the length of these strings, you can perform validation checks, identify unusual entries, or categorize data based on string length. For instance, you might use the length function to verify if certain codes conform to a specific length or to identify if some entries have missing or incomplete information based on their length. Additionally, calculating string length can assist in data transformations and standardizations where a certain character count is needed. The length function essentially makes it much easier to manage and clean up textual data, allowing you to quickly gain insights and ensure data consistency in your PySpark data frames. Basic syntax. The basic syntax for using the length function in PySpark involves importing the length function from pyspark.sql.functions. Once imported, you can use the function to calculate the length of a specified column. To do this, you apply the length function to the desired column within a data frame using the select method, and you can also give an alias to the result such as column underscore length to make it more descriptive. The column parameter refers to the specific string column for which you want to determine the character count. By using length, you can easily create a new column that holds the number of characters for each row in the selected column. This is useful when analyzing text data, allowing you to compare the lengths of strings or to use these calculated lengths for filtering, validation, or other analytical purposes. This straightforward approach makes it convenient to add new insights or metrics directly to your data frame, enhancing your ability to work with textual data in PySpark. Why use length function? The length function in PySpark is very useful for analyzing and validating string columns. It comes in handy when you need to ensure that certain values meet specific length requirements. For instance, you might use it to check if usernames exceed a certain maximum length or to validate that product codes are the correct length. This kind of validation can help you identify errors or inconsistencies in your data, making it easier to catch issues early in your data processing pipeline. In addition to validation, the length function is also frequently used in data formatting and preparation tasks. For example, you might need to standardize the length of strings or filter rows based on string length before moving forward with further analysis. The ability to measure the number of characters in each value allows you to make informed decisions, especially when dealing with data quality and consistency. Overall, the length function is an essential tool for working with textual data, helping to ensure that the values meet expected standards and preparing data for efficient analysis or modeling. Practical examples. 1. Calculating the length of a single column. In this example, we are working with a data frame containing a column named product underscore code, which consists of alphanumeric strings that represent different product codes. Our goal is to determine the length of each product code, which can be essential for a variety of use cases such as validating data integrity, ensuring standard formatting, or performing analysis on text data. To achieve this, we use the length function from pyspark.sql.functions. This function calculates the number of characters in a given string. allowing us to measure each product code's length. By applying the length function to the product underscore code column, we create a new column named code underscore length that stores the length of each entry in the original column. We use the select method to specify the transformation, and we give the result an alias code underscore length so that it's clear what the new column represents. The resulting data frame will display each product code along with its corresponding character count. This new view provides immediate insight into the structure of the product underscore code data. For example, if the product codes are supposed to follow a standardized format, checking their lengths can help identify any discrepancies or errors that need correction. This operation is helpful when working on tasks like data validation, data quality assurance, and preparation for further analysis. It can be used to filter out entries that do not match the required length, ensure consistency across datasets, or simply provide additional context for other transformations and analysis. The length function thus becomes a powerful tool in the data processing workflow, particularly when handling string data that requires specific formats or constraints. To calculating the length of multiple columns. In this example, we have a data frame named df underscore names that contains two columns, first underscore name and last underscore name. Each row represents an individual's first and last name. Our goal here is to calculate the length of the values in both the first underscore name and last underscore name columns. To do this, we use the length function from PySpark.sql.functions, which calculates the number of characters in a string. We apply this function to both the first underscore name and last underscore name columns using the select method, and we assign descriptive aliases first underscore name underscore length and last underscore name underscore length to the calculated values. By doing so, we create a new data frame that includes columns representing the length of each first name and last name. The resulting data frame will show the length of each first underscore name and last underscore name, making it easy to analyze or validate the data. For instance, if the names are expected to be of certain lengths, this approach allows us to quickly identify entries that do not meet the expected criteria. Additionally, it can be helpful for text processing tasks, ensuring consistency across data records or analyzing patterns, such as identifying the most common length of names in a dataset. This type of length calculation is useful in data quality checks, where we may want to verify that all names adhere to a certain length requirement, or in data exploration when we are interested in understanding how the data varies across different entries. Ultimately, the use of the length function here helps us gain a more structured understanding of our dataset, ensuring that our data processing steps are robust and reliable. 3. Filtering data based on string length. In this example, we are working with a data frame that contains a column named product underscore code. Our goal is to filter the rows based on the length of the product underscore code. Specifically, we want to retain only those rows where the product underscore code has a length of 8 characters. To achieve this, we use the length function from PySpark.sql.functions, which calculates the number of characters in a given string. We then apply a condition to filter the rows using the filter method, ensuring that only rows with the product underscore code of exactly 8 characters are retained. By using this filter operation, we create a new data frame that includes only those entries where the length of product underscore code matches our requirement. This kind of filtering is extremely useful when working with data that needs to conform to specific formatting rules. For instance, product codes may be standardized to always be of a fixed length, indicating a specific structure or category. Using this approach, we can easily identify and filter out any data that does not meet the length criteria, helping us maintain consistency and data quality. The result of this operation is a data frame that only contains rows where the product underscore code is exactly 8 characters long. This ensures that our subsequent data processing steps are performed on correctly formatted data, reducing the risk of errors or inconsistencies and improving the reliability of our analysis. 4. Handling null values in string length. In this example, we are working with a data frame named df underscore with underscore nulls, which contains two columns, first underscore name and last underscore name. Some of the rows in this data frame have null values. Our goal here is to calculate the length of the strings in both columns, including handling situations where values are null. To accomplish this, we use the length function from PySpark.sql.functions. This function allows us to calculate the number of characters in a string. We apply the length function to both first underscore name and last underscore name columns, giving them descriptive aliases as first underscore name underscore length and last underscore name underscore name. The result is a new data frame containing these calculated values. When we use the length function on columns with null values, the function returns null for those entries. This behavior is helpful in understanding which values are missing, as it distinguishes between valid data and null values that need to be handled further. For example, in the resulting data frame, if the first underscore name is null, the first underscore name underscore length will also be null, allowing us to see clearly which data points are incomplete. This type of operation is useful in scenarios where data quality is crucial. It helps us verify that our data is complete and meets specific criteria, such as ensuring that all names have a minimum length or identifying missing information. By explicitly including these length values, we can further filter or clean the dataset to meet specific requirements, ensuring that our downstream data analysis is based on accurate and consistent data. 5. Combining length with other string operations. In this example, we are working with a data frame named df underscore names that contains columns first underscore name and last underscore name. Our goal here is to create a new column called full underscore name, which combines the first underscore name and last underscore name, and also calculate the length of this newly concatenated full underscore name. To achieve this, we use the concat function from PySpark.sql.functions to combine the first underscore name and last underscore name with the space between them. This concatenated value is given the alias full underscore name. This approach is particularly useful when dealing with data that requires merging multiple columns into a single one for display or analysis purposes, such as creating a complete name from separate first underscore name and last underscore name fields. We then use the length function to calculate the number of characters in the full underscore name. This value is given the alias full underscore name underscore length. By doing this, we can see how many characters are present in each full name, which could be useful for further data validation, formatting, or other analysis. The resulting data frame contains two new columns, full underscore name, which contains the concatenated version of the first underscore name and last underscore name with a space in between, and full underscore name underscore length, which provides the length of each full underscore name. This kind of operation is essential in situations where names need to be combined and verified for completeness or standardized length, such as preparing data for customer records or addressing formatting. Using the combination of concat and length functions together allows us to efficiently generate the full name while also validating the combined values length all in a single step. This approach ensures the data is consistent and that there are no anomalies with incomplete names, making it easier for downstream processes and ensuring high data quality. That's it for today's video on the length function in PySpark. Now you can easily calculate string lengths and use this knowledge to improve your data processing tasks. I hope you found this tutorial helpful and that you're ready to put it into practice. If you enjoyed the video, please give it a thumbs up and consider subscribing for more data engineering content. Don't forget to leave any questions or suggestions in the comments below. Thanks for watching, and I'll see you in the next one.